Are you ready for this? Excuse me. Got a little bit of a stuffy nose today. I got something for you here. This is funny. Maybe. Maybe it's not. We'll see.
Retro coding live stream, everybody scream. Retro coding live stream, everybody scream.
Alright, it's not much of a theme song. But here we are. Back here at the 6502 Tools project. It's been a lot of stuff going on this year in retro. My main focus has been on Marlin, but on the side and on occasional weekend evenings, I've been playing with going back to the old school stuff and just sort of cleaning up the tools that I have for playing around with it, kind of getting myself set up to do things. I thought I'd share some of what I've been working on with this retro coding tool set. So I quit Ace Step, which was fun at first, but kind of is starting to sound the same every time. Let me see, what else can I do? Oh, right, let's get Ace Step out of here. Okay, bye. All right. So what have we got going on? We'll make that a little larger. Don't need it to be that large. Maybe that'll be good. Then that's fine. So anyway, if you're not familiar with this project, this is just tools mainly for Sublime. To be able to build and run mostly Atari BASIC right now, but also some help for 6502 code. So you've got, excuse me, I don't know why I'm so stuffy today. More caffeine will help, right? Anyway, where were we? Oh, right. So we have. Mute that. We won't need it. All right. We've got. You can take a look here. Mainly, what I've done is made a little thing, a theme, so you can use your Atari font with Atari Basic, and it has. You have certain fonts. They have UTF-8 support now for the characters that appear in Atari ASCII, the extended character set in Atari, which are graphical characters and little hearts and, you know, suits and and things like that. Um, excuse me. Um, so anyway, yes, we'll be editing this one down. Atari Tools settings. You know, is a place where you like tell it where you're. So yeah, you're like, oh, let me show you what's in the project, give you an idea of what's in here before I go too far with anything else. So let me bring this up here, close everything, bring it over, boop. Okay, so that should be it, yeah? Good. So here's the project. And in Sublime, you bring this into your user folder and drop these things in there. So if you're using, let's see, I haven't used this in a while. Let's see, that's the right folder. Let me go to my library. Boop. Hold on a second. guess I could do it over here. So if I was in the Finder, I would go to Library, and you hold down the Option key to make that appear. And then I would choose Application Support. Boop. And in the Application Support, Sublime Text 3, in this case, haven't upgraded yet. Packages, User, and then I put them in here. So there's Atari Tools, and there's 6502 Sublime settings and other things from the project folder, which I guess I put them side by side, you can see. That, yeah, indeed, I've got that. Atari 800 Sublime build is in there somewhere. So mostly the Atari tools folder has stuff, but then the other things are like the Sublime settings, which just provide a good starting point for 6502 and Atari BASIC and so on. There's also a case insensitive version that I've been working on. It's not quite ready because I need to make the tokenizer first. But what's working on this so far is that we have a syntax. So, you know, that'll give you a syntax for Atari BASIC so it appears nice when you look at it. So when you look at a bit of Atari BASIC, like this tiny menu here, you can see that it has syntax highlighting. The commands are green and variables are yellow and numbers are white and functions are blue and so on. And then these dividers and comments are dark colored. And then if you have something like this where a run command is at the end of a line and then something follows it, it's like it marks it in orange as a warning, not an error. If I was to put something weird there, like, you know, I have no idea what you're talking about, or, you know, like if I was to say Ruxin, like, you know, or whatever, it would be like, I don't know what that is. So it'll mark stuff in red that's an error. So it's pretty good at parsing Atari BASIC. So this is a tool set for that. And then if we scroll down, let's see, if you're into 6502 syntax, I was using my own sort of built from various, cobbled together from various sources, and then more recently I made a new version. I pulled a new version down from like someone else's project and used that basically, and then made a few tweaks to it. So it's the credits are in there, but let me bring that up. A6502, I'll bring up a 6502 code. I think I've got some here. So if I bring up some assembly code, like all it does is, you know, colors it out nicely for you and so on. So the one that I picked, like that's in the package now, is better at all this. And its actual syntax file, if you look at it, is 6502 Sublime syntax. And there's a lot of stuff about it. And please help improve. I think this might still be the unimproved one. I have a new one I'm bringing over. I might not have brought it over yet, but in any case, it's not too bad. It's readable. So it does that for you. Let's see, what else does it do? It gives you the ability to do a build for, you know, Atari VCS. So if you happen to be using, let's see, DASM, the DASM assembler, with VCS libraries to build something for the Atari 2600, it'll build that and it'll run. It doesn't. Oh, I mentioned Atari 800. It should be running in Stella, so I should mention that it doesn't kill Stella there. But this is copied from another paragraph, so it doesn't kill Stella like it should. So we'll fix that. The README of, we'll say Stella. Then that might not be a thing that matters for Stella. But anyway, the idea is it builds it and runs it for you so that, you know, you can quickly iterate. There are probably, right now, I know there are some tools in VS Code, plugins like Atari tools that are probably also good, and I know they adopted some of my work on the Atari BASIC syntax in there, but I still need to probably fix. Like, it doesn't do expressions very well, like properly, probably at all. So I need to work that out. But otherwise, it does good. It does good stuff. It manages to get through expressions without falling apart. So, but as far as telling whether the parentheses are balanced and things like that, I'm not sure. So anyway, then there was a lot of interest in Batari Basic for a while, but it's kind of like lost steam because the games that are made with it tend to be very similar to each other. And if you really want to do 6502 coding on the 2600, the best way to do it is to really dive in and make your own kernel, and really like go for it. And but you don't necessarily have to start from scratch. Of course, you can find a lot of examples of games that were made for the 2600, or decompile them yourself and get all the tips, because once you learn them, they're like things that'll stick with you if you want to do that kind of retro coding. And I think there's still some there's some forward interest in it. Maybe not going to make $1 million doing retro coding, but it's a lot of fun, and you can kind of get into it. I'll show you in a minute what my recent workflow changes are and what I've been doing to kind of try and speed things up and get more into it and not get stuck, and to move forward with a game concept without having to pick a particular assembler compiler. Well, I guess I've picked one at this point, but working my way through like techniques to reacquaint myself with the system and get sort of like my ideas worked out and then prototyped, and then kind of like if I can build it in BASIC with a little assembly help and get actually something really working that way without having to run it through a compiler like the ABC compiler, which I'll mention in a bit. Yeah, that would be kind of cool, because really, if you can get Atari Basic, to be optimized, and then only really, like trust the parts that are okay, like the scaffolding parts, like are okay. The things that suck are go-to and go sub suck in Atari Basic, so you want to avoid those as much as possible. So when possible, if you can do something like within the loop without go subbing somewhere else, you're better off doing it that way. Um, anyway, the although four next loops also are basically a go-to, so they have their issues. But I think I have to look at the way that they're implemented again, because we do have that as part of this project. So the other thing that is, well, anyway, going back to Batari Basic, if you've used it, it's basically a basic like thingy that you can use. I hesitate to say language because it's language like, but it's basically it's translated from what you type in into assembly code, and then that assembly code is assembled. This is not different from what is done in, say, a C compiler per se, but I would say it's much simpler. It doesn't have that kind of like tree-like structure thing going on where there's a lot of like nested things and so on. Or if the structures are there, they're not um like semantically, I don't know what I'm trying to say. But if you look at it, you can kind of see that the way that if you look at the code, it's like it's almost staggeringly simple. It's not pulling in a bunch of weird language libraries for doing parsing and that kind of stuff. It's really rolling its own. So make of that what you will. But the idea is it already has the kernels pre-built. So a lot of what you do is you're calling stuff that's, oh, relevant to the kernel. And so you don't really have to think too much about the details of the machine below the kernel level. You can just call the kernel to do the things you need to do. But you still have to worry about like knowing that the fact that there is like a background and it's got certain mirroring capabilities, and those things change over time, and what line you're on matters, and as far as this keeping up with the beam, all that kind of stuff. Atari Basic covers a lot of that for you, and it's a good way to like, again, you can build your own kernels with it, so you could get away with doing some things using Batari Basic, because the one good thing about it is it provides a high level overview. Like again, it's like Atari Basic, which I'm going to talk about in a minute itself, using it as a scaffolding. Atari BASIC is a good way to do scaffolding for a 2600 without having the ability to run, say, BASIC on a 2600. You run the compiler on a Atari BASIC and so on. I went through all this process of like cleaning up the code, and that's what I was sort of. It seemed kind of languishing, so I grabbed a fork, I cleaned it up, did a bunch of things, and then they never really took my contributions into the main fork, so mine might have other changes that aren't exactly there. I would like to go back to it and refix it because that these days you could run some stuff through an LLM, I'm sure. I know there have been versions that have been recompiled into like WebAssembly and stuff, which is a cool way to do it. But I think the best way to do it would be to rewrite it in uh, again, another high level language, maybe, get a Python version, I don't know, re-implement it in various ways. JavaScript would probably be good, especially for the purposes of running it in the VS Code environment directly and being able to just compile, the code as you're typing it, for example, and have it compile directly and catch errors as you're typing them, that kind of thing. Those are all things that I think would be fun. Again, it's been what is it, almost 10 years, 9 years since I've really touched it a lot. It's been a long time. So if interest rekindles in Batari Basic, I think that'd be very cool. Meanwhile, I do have a syntax for Batari Basic. It's not great, but it's fine. Um, and I don't know if I have any, actually come to think of it, I don't know if I have any Batari Basic examples in here at all, which would probably be a good idea if I bring in a couple. Yeah, I don't. Well, you can find them. They're around. That's a yeah. I'm working out sets of I'll show you in more detail what the files are, but let's continue. Atari Basic support is again I had the most fun with this because it's the language I cut my teeth on, and it's a fun language to like have. And I think also if I could find, I would love to do the same thing as far as the theme and syntax for the uh, Commodore Basic. Maybe someone has already taken my work and extended it. I don't know. We'll take a look. But yeah, if that could be, it would be really good. The syntax I built it isn't great, and you could probably find a more complete set of syntax rules in another syntax for doing expression evaluation, parentheses, balancing them and recognizing things inside of them and what the rules are for what's allowed inside and so on. Um, Effectively, I could also like you could use the BNF itself, which is the Atari Basic code that describes the basic language itself, the meta language. That could also be kind of, I think it's called ABML. You could also use that as the basis to build a syntax that's a little more effective. But the one that I have is fine, honestly, and it does what it needs to do. Generally speaking, you just want it to look good. As far as like, I wanted it to kind of balance out in such a way that it would match up and have parity with the compiler and the the ABML rules and the BNF rules. But some of the rules are a little more complex. And I think that what we would say is like the rules were more complicated in the original Atari Basic code because they had to run code to do evaluation of things like, is this a string name? Is this, a legal, whatever variable name? Things like that. Versus what we would do now, which is just do a regular expression match, and that would be is much simpler and inline as opposed to having to call something. So there's some tricks we can do to make the syntax match up better. It's an iterative process. That what I have there is a good starting point. So anyway, that's one thing. Then I also have a Sublime settings for it, which is just like tells it to use the theme when you use list files. So when you open a LST file, you get this appearance automatically with the background and the colors and the font and all that. The font that I have installed at this time is, let me get that setting. is it Atari BASIC Sublime syntax? No, not there. There it is. Sublime settings. The font is 8-bit Atari is the one you want. So get that one. These others also have the same UTF-8 mappings and stuff. So, you know, Atari Classic, regular, Atari Classic, chunky. But the one that I recommend and is listed on the page is Atari, 8-bit Atari. So you'll find a link to that on the project page. So basically, we have a syntax, we have a theme, we have some settings to set up the syntax for you. We have a build. Yes, so now if you want to actually run something, all you have to do is, once you've installed your stuff or before you install it, set up your Atari tools.sh file. We don't need that right now. I have some language server thing on right now that wants to activate, but right now here we have, so where's your emulation directory, where's your Atari 800 executable, what options do you want to use, what window size and so on, colors preset, you can, where's your Atari 800 custom files, like things like your hard drive folder, and where you can, and it'll bring that hard drive folder in to the arguments when it runs the emulator. Then you tell it also where your VCS folder is, like where your includes are, and then where your Stella app is. So these are some things, and then where your print file, when you want to name it, and where you want to name your print file. So that's when you use the printer device. It saves it to a file and opens it up in Sublime or your editor. So that's useful because usually you're saying something like list :p:, and it comes out. So I can show you that. But the idea is that, yeah, this is that. So anyway, once those are set up, all you have to do is when you have a file like this open and you run it, it will automatically run. Right there, I just hit Command B. So I should probably show you that in the menu. So if I go Tools, Build, so right now the build system is Atari BASIC, and it will select that automatically for you, along with the language syntax and so on. And once that's done, you say Build. Once you have that selected for your language, you can just say Build, boop, and it will build it and run it in the emulator of your choice. And you also have the option to run it in, I say build with, I have tokenize, which is not ready yet, but, well, it is kind of, it'll just load it, but it won't run it. Then it runs it, so it's effectively tokenized. Then it runs it, and then you also have the option to run it in Atari 800 Mac X if you have a copy of that. So those are the things you can do to run it, but with the build. So a build of an Atari BASIC code is to run it. So things like this, if I build it, boop, and opens up in the old emulator. And sometimes the fun stuff is just to see how fast your code runs and if you can optimize it. This is basically how fast, it's a cycle for cycle accurate emulator, supposedly. So when this is running, this is just how slow drawing a line would be. It would like move as slowly as a Star Wars blaster across the screen, which made it cool for Star Wars blaster effects. But also, just make it, you can see it's very slow. Today you would see something more like, this. That's just turning off all the delay and letting it just run as fast as it can. Turbo baby. But yeah, so that's how slow things would run. So you can imagine if you wanted to do like, that's basic. So if you want to do real animation, you have to really get into assembly pretty quickly. But So anyway, this is for just, a quick way to be able to build stuff and run it in there. And so good for turnaround. Um, I'll come back to that in a second. So back to the web page. Um, it comes with helper scripts like the Atari Tools one, which I just showed you, which you have to edit to change where your hard drive folders is and so on, and where your emulators are. Once you point there, you're pretty good to go. And then these are files that come in the project are just part of the build. One for Atari BASIC. It'll do it with it'll run all the things that need to be run to build a Atari BASIC file. Then you have one for Atari VCS. You have one for Atari BASIC to run it or build it. Yeah, well, no, I guess just run. And then Atari 800 build. This is meant to run code that would be written in Atari assembly language using CA65 and CL65 or LD65, I guess, which are the assembler and linker. So when you build, typically when you build a project, you're going to be building multiple files. So I recommend generally just using a makefile, setting up a makefile and maintaining that for your assembly code, and then not using this. This is mainly for, like, I think a single file assembly language. Now, a lot of stuff can be done single file, so that's pretty cool. Like, you can look at something like Star Raiders, which maybe was written originally for many files, but you can, I guess you can probably break it up using include and just use it, run it that way. But you need to be able to build from the main file. You need to be able to get all the code in there to build it. So other than that, and then you also usually for your build system, you need other supporting files that go with it. And that's the case with CA65. You'll need like a linker file and so on. So how this knows what the name of this knows the name of the thing you're going to build based on what you give it, and I think it uses the name of the file, strips off the extension, and looks for the the appropriate linker file with the same name and so on. So we then have Atari to Sublime, which is a little conversion script that wraps a thing called a ATASCII, which is, I think I've written one. Yeah, I wrote one in C, and then I wrote one in C++, and one in Python. Anyway, that's the binary. That's the C++ version. But this is just a file that just converts the characters from UTF-8 and to ATASCII and back again. So when you need to pipe things for printing out of the machine to a file that you can look at in Sublime and see the UTF-8, it converts it to UTF-8 on the way out, and then you see the UTF-8, you work with it while it's in UTF-8. I was also working on, which I don't know if it's working right now, but a plugin for being able to do the characters. Let me see if I have it enabled at the moment. No, I don't think I do. Let's see, it's Unicode. No, I don't have it enabled right now. Too bad. Well, I'll show you that sometime soon. Yeah, it's not working right now, but basically, and maybe it doesn't work. It doesn't work in here either. No, okay. It might be that I was working on it on my laptop, so I'll get back to you on that. But I have one that it's like a plugin that will let you select your ATASCII weird characters from palette. So I'm adding that. That'll be in there soon. But anyway, the idea is you need to be able to convert between those. So that's what these do. That's all about. Then I have a tokenizer, which I think I've deleted this file now. But the idea is I'm working on it in another project file and another branch. I'm working on the process of getting through writing a tokenizer, but it's a long process. I could just do it by rote, by just like, okay, I know what it's looking for, and I can just go, let's do that, and let's get this rule, and let's call that, and do this. kind of, step by step. But as I look at the problem, I'm like discovering all kinds of interesting factors about how do I build it in the language, and what kind of scaffolding do I build around it to be able to evaluate these things within the terms of the language I'm using, which is Python in this case. And so I have other videos where I'll talk about that, but the process of writing a tokenizer for Atari Basic using the documentation and original Atari Basic source code as reference is very interesting. Maybe not for this video, but just catching you up on what's going on with this stuff that I have for Atari Basic support, and a little beyond that. So then the other stuff I'm working on is the Atari Basic source book, where we have the actual Atari Basic source code itself, which was a real mess. I grabbed a version of it, which is this one from, I don't know where I grabbed it from. I grabbed it from Atari Age, so I don't know who grabbed it, but it was a pretty good one. It was a good dump because it was buildable, but it didn't have some issues which I mention here, so you can read up on what I missed. But basically the idea is that needed a lot of cleanup, and then I also wanted to match the comments to what was in the original source code, so I went through and I made sure all the comments matched up, so we have a very complete, at this point, and good version of Atari Basic source code from A00 to BFFF, which is like, what's that, 8K? It's an 8K ROM. Pretty amazing how much you can do in an 8K ROM. So there's a lot of things about this BASIC which are not optimal. So let's get into it. And that's why we're here. What I'm here to talk about is how do you get more optimal with such an unoptimal BASIC. So you can read the source code and you can figure out why it's not so optimal. A lot of it is everything is 6-byte binary coded decimal numbers, or I don't know if it's not BCD or whatever it's called, but it's a 6-byte encoded version of a floating point number. So anytime that you want to like have a line number, even the line numbers are when they're evaluated as you type them in, are evaluated as floating point numbers. So if you type in 0.3.7 as a line number, it's a valid line number in Atari Basic. But it won't it won't keep it there. It'll turn it into an integer, but it'll treat it as 3. So that's pretty cool. So yeah, you can check out all the weird things about it. The source code has now been cleaned up. I then also went through, and I've got another branch where I've started to expand on this a little bit and put more commentary in and clean some things up. I did a lot of cleanup. This is one particular part where I did a lot of cleanup, which you'll see is the syntax tables, which describe Atari Basic itself and how it's all supposed to be parsed and what the rules are for each command and so on, and the rules for expressions and so on are all in here, and they're all described using these little basic macros that are like, don't look too closely, they're ugly, but the idea is that they encode for bytes in a byte array, and then so they're more readable. So this is like, if you see something like this, that's like close parentheses, and then this is looking for an expression, and then this is a right parenthesis, and then it's calling another thing, which is an expression, which rule, which is itself, I guess, and then it could have and then it has a right parentheses, and then a no op, and then or means, oh, there's another, this rule is over. If it failed, maybe this next one's okay, so it'll check the next rule. And you can kind of, if you read this, it actually makes a lot of sense. But it's a twisty maze of rules that refer back to one another and so on. Some of them are fairly simple, like must have 6 arguments, and then it goes and says, what can those arguments be? They must be numeric, so it has to go and figure out, okay, is this an expression? Is this a number? All the things that are legal to be a number. And so all that stuff is encoded here. And I went through and cleaned it up real nice. And it runs, and it does compile, and it's all accurate now. And if you do read through, you can kind of see what the rules are. They're all commented to kind of match what the original comments from the code in the source book were. I did this on a cold winter night, drinking claret or something. I don't know what, but but it was a long process. It was a lot of fun. I would totally recommend reading this, and also look out, watch your eyes. I'm about to open a PDF reader that doesn't have uh, color, like dark mode. So, ow. So if you have the if you go to the archive.org, get this, the Atari Basic source book. Highly recommended. Which I'll go to the top here. Oh, there it is. How Atari Basic works. So, part one. So this goes through in excruciating detail. This was written in 1983 or sometime around there, and goes into all the detail of how the language works, which was written in 1979 ish. All the compromises they had to make to fit it into the space, and some of the compromises include things like these weird things about line numbers being, floats, and or at least at first interpreted as floats, but then converted into two bytes. So there's routines to do that kind of thing, and so on in the OS, and in the basic language. There's some other add-ons that go with that, but I highly recommend grabbing a copy of the Atari Basic source book and reading through it, and seeing how all this 6502, which is also, again, a big bulk of this book is the actual 6502 language itself, which includes that big, you know, set of rules that I showed you a second ago. Although I think my version of them looks nicer than what's in here, so don't look too close again at anything. But basically, if you read the most cool stuff about this book is the things like handling correct lines. Like how does what is it doing at each stage of the compilation or the tokenization process? As it's doing the tokenization, it's also validating, is the line correct? And then if it gets to an error, it just throws out everything and says error. Oops, puts error on the front of the line and the text of the line, and that's what it gives you back. So it's kind of simple in that way. It doesn't throw an error at a certain point in the line. It just says the whole thing's bad if one part is bad. But uh, but it can, it does some cool things in saying, well, if this part of the line is bad for this particular rule, then I still need to be able to back up and say, okay, let's throw out this little scratch pad that I made so far and start over with a new rule in the case of those OR rules and so on. So yeah, the BNF describes all that. It just goes through it. Once you have a BNF executor, it kind of just bloody well works. It's kind of cool. I'm not going to be writing an executor. I think I've mentioned this before because it's a lot of hassle. But some of the things about this executor, since we have one already, basically, why would I write one? I would need to create an emulation environment, which again we already have. The one thing I would ever consider doing is making a thing that just lets you control the hardware of the emulator without having to use any language. Just control it directly from outside the emulator using Python or whatever. Just go nuts, change the screen, RAM, do all that kind of stuff from outside, while the emulator is running in real time or whatever. You can do things like you could write games that are specifically targeted to run through an Atari emulator, but are coded entirely in modern, languages of any kind you wanted, as long as you had a patch that could connect to it and modify its memory. You would be able to do anything you wanted. So at that point, you've got pretty much, carte blanche to do whatever you want. So that's something to look at, though. I think that'd be fun as a process to make something like that. Anyway, what we're looking at today is the compromises of this language, Atari Basic. So one of the things that's interesting about Atari Basic is that numbers, again, all these numbers, regardless of the fact they may not only be used ever as integers, are expressed as 6-byte float or decimal numbers. So when your program, you only have a certain amount of memory for your program, So how do you deal with that? Like if you want to make a program that's like very large and suddenly you're running out of memory, but you need, to get that one feature in, how can you save memory? Well, one way, which we use a lot, and I'll just pull up something ordinary. How about this one? Is, yep, is you will nope, it's not even assigned. So yeah, n0 you don't have to assign because it'll always be 0 by default. But yeah, so this particular thing, go see if this has 10,000, where it is. Oh yeah, it just reads them. So I was assuming it would do something different. But anyway, we read these values, some common values, 0, 1 through 8 or whatever, from a data statement, or you can just do assignments or whatever. I think reading them is probably, uh, the code might be smaller to do that because this is stored as text in the code, as opposed to these won't actually be numbers. This will just be the text in the data statement, which will be converted to numbers as the read statement goes on. So this takes up less space. So that's kind of one of the tricks for optimization. And now the other thing is, if you then substitute all these numbers that you use commonly, 0 through 10 or whatever, with n0 through n10, now each number, instead of taking 6 bytes, takes 1. So you're saving 5 bytes for every single integer of a certain size, under a certain size that you use. You can use it for line numbers, you can use it for all sorts of things. It'll make the program slightly slower because it has to do a fetch instead of directly from the program tokens. It'll be fetching it from a variable table, but it's one way to make things faster, or smaller, I should say. And the speed up or the slowdown is not noticeable. It's not enough to really care, honestly, for most cases, including if you're writing games and stuff. This particular game that I'm looking at right now is from a Softside magazine, which I'll be talking about in a future video. And this it was written in Atari BASIC, and it's a little Defender type clone, but it just goes in one direction. You can speed up or slow down, and the aliens just kind of like randomly appear. It's pretty cool, but it's very very rudimentary. It's not the version that they shipped on cartridge. That's for sure. The version that Atari made was pretty good, to be honest. It was like one of my favorite ports. It really was. I was hooked on it for a while. Uh, so anyhow, another thing about this language, as far as speed goes, is because of its compactness and because of the amount of memory that you only had a certain amount of memory. Typically, about 48K free, maybe if you were lucky, to use for your program. And if you could have up to 32,768 lines of code, from 0 to 32,767. If you managed to use all those lines of code, you're, out of luck. You had to, figure out ways to consolidate. There are a lot of ways to consolidate, though, and we'll get into that. But one of the cool things about this language was that, yeah, you could have all these lines, but in order to go to a line, it had to search through all the lines from top to bottom using little, basically a linked list type thing where each line has its length. So basically a pointer to the next line. So if the line number doesn't match what you're looking for, it just goes on to the next line, and it starts from the top and it goes all the way to the bottom. And there's no backward like reference, like where, distance to the previous line or anything like that inside of your code. So there's no like, as far as traversal goes, there's no way it could do, say, go into the middle line, in the middle of the program, find a line there, and then start from that point and then go halfway, halfway, halfway until it finds it, which would be, would reduce a linear search time down to a, quadratic or, square root search time, something ridiculous. So yeah, it's funny, but effectively, or log2 search, I don't know. But log and search time, I don't know. But yeah, whatever. funny, but they had to do the linear search because you think about it. If you were going to do, say, store an array of pointers, you would need 32,768 pointers, which are each 2 bytes, or if even if they're offsets, they're still 2 bytes, and so that number of pointers is going to take 64K of RAM just to store those pointers. So it wasn't viable to do that kind of thing. Like we would just, today we'd just throw it away. We'd just be like, oh yeah, give me a little index that I'll store separately if I need to find something quickly. I'll just go straight to the index. We'll just keep the index updated periodically, or whatever, as we update the linked list. So yeah, it gets weird, but so yeah, it's pretty fun stuff. So there's a lot of optimizations you can do around that, which is basically if you need to use code frequently, or you need code to be like if you're gonna have a go sub or a go to, make sure it's near the top of your program so that the search time on it is minimal. It'll take some time to find it. All go tos take some amount of time, including the one that starts at the very top of the program. Is the only one that's optimal. Every other one is like slower and slower and slower until you get to like the bottom. Make things you only have to go sub once. Put those at the bottom, at the very bottom. Put things that need to be used frequently at the top or need to be fast at the top. And basically that. Um, and so I haven't optimized a lot of things. Like here's a golf program that was in Soft Side magazine and a mini golf, and you know it's like you can see that the language, by the way, is very compact. You can squish things together and it'll figure out that, oh, this is where this is a then keyword, therefore this must be a variable. It doesn't need spaces to delineate certain things, but if this was a variable like n0, now I have to have a space there at that point. So yeah, you can kind of see the cool things about the language, and you have every keyword has little abbreviations that you can use, so that's pretty awesome. Most do, at least the longer ones do for sure, which is nice. It makes it smaller. This will load more quickly when I load it up in the emulator, so that's kind of cool. There's right now there's a couple of channels showing off like type-in programs, and these are mostly right here. They're type-in programs from soft side, from compute. This one is from soft side. Here's some compute switchbox. Recently, there was a switchbox on Commodore 64 that was featured, and I like those videos. I watch them frequently, and sometimes comment on them and say, "Oh, I'm nostalgic," which I am because this was the fun. Things were so much simpler when you had 48K to work with, 64K, and weird hardware that you had to do certain ways. So, this one I haven't optimized yet, but I think I did start. I put some variables in to make the code smaller anyway. Making the code smaller doesn't necessarily make it faster. It just makes it smaller so that you can write more. And I learned those tricks mainly because I had to for my own coding back in the day. I was writing stuff for like you know uh, trying to write games and things, and I got to this point where I was like, okay, now I need to write tools, and then so I would start writing tools, and then I would go crazy, and my tools would grow and grow, and like uh, to use up all the line numbers, and I would have the compiler to make it optimized and stuff. But the running out of line numbers meant that I had to consolidate, and then of course I was running out of memory, so I had to use any trick that I could find to like make the code smaller. So putting things in variables was like one trick, of course, you learned early on. Uh, but yeah, so Switchbox, that's one that was recently featured, and it runs okay. If I can quickly run it in the emulator here for you, and I can do a quick turbo on it. Layer 1. Oops. No. Let's try that again. I gotta turn off the turbo. Bob. Yes. So Switchbox, pretty cool, right? You can see it takes a while to draw, right? So you can imagine you could certainly, I mean, it's kind of fun to watch, obviously. but all those kinds of things where it's drawing the little seats and stuff, which are just character graphics, and it's not even custom character graphics, just the built-in ones. Uh, and you could optimize that drawing in a lot of ways. You could probably have this whole playfield drawn using some optimization method. And now this is only 40 by 24, so you kind of get to cheat on the vertical. You know, everything you draw is like takes up an entire 8 scan lines of area, so you get to draw more quickly. But in general, pretty fun game. You just type the number that you want to play, and down the thing goes. Yeah, until it lands on the, I don't know what these are, the edge of a seat, I guess. I'm not sure what you call them. Right, and so now I might say 8, and whoever gets the balls to fall into the bottom is the one who scores. On this level, all the scores are 2. Let's go for it. Ooh, cool. And then I make one fall. I guess the little arrow is pointing to the left, so that would be player 1. And see, as they fall, the thing flips over. And as you can imagine, you get into it and it creates chain reactions. And so things can end up being way over to the left and way over to the right if you play it right, and they'll get higher. You'll get higher scores for those later levels. I don't really know all the rules, but it's kind of fun. It's like a pachinko kind of parlor kind of thing. Yeah, a fun one. But as far as the way that it falls and does the processing and the calculation of the next move and so on, the more things that are moving down, the slower it is, and you can really feel that. And it really, and like each one adds like, you know, to every other one or something. I don't know what it is. I think it scales linearly essentially. So this would be fun to optimize a little bit in that way and maybe draw with prettier graphics as well. But overall, pretty cool thing. And I typed it in over, some time and cleaned it up a bit. And I had some typos as you do. But once I got it all typed in, I was quite happy with the result. And of course, this is the cool thing with, a lot of these type-in programs back in the day, you would have to type them in using your old Atari keyboard, and it wouldn't be fun, and it would kind of sucks in some ways. If even typing it in on the emulator would really suck. Although that could be a good exercise for a video to just like do let's check the difference between typing it in on an emulator versus typing it in on, say, a modern, in an editor like this, where you can just duplicate the line, and do all those other tricks that you need to do. And, let's just duplicate that part of the line, or whatever. You can just do all the tricks you need to do with a modern editor and go exactly where you need to go and copy paste all day. Whereas with the old one, you had, very limited editing abilities and so on. So it kind of sucked in a lot of ways. It wasn't the most pleasant experience, but it was meditative, and but anyway, so with all these kinds of optimization ideas in mind, what do you do when you run into the things that you can't optimize? Like, I want to draw graphics on the screen, or things you can't even do, which is I want to do like player missile graphics, which are painful to do with a for next loop. Although a lot of type-in programs have actually done them with for next loops. So yeah, how do you deal with that kind of stuff when they're so painful? So what I've been doing lately is, let's get my Thinkyhead folder here, and I've been working on Snorky. So this is you'll see I mentioned at the top here an homage to Qbert. I originally started writing the game in 1983 or so, and it was just, I had gone to the arcade, and as you do, and every time I went to the arcade, I was looking for inspiration to make another game and clone and see if I could achieve it. and I'd find a game I liked and see if I could write it. So Dig Dug was one, and there were, Crazy Climber was one that I did pretty well. Although again, all this stuff is lost forever. But I think I used like line insert characters to make it scroll down. And then, so I wasn't using any fine scrolling or anything. It was all written in BASIC. And you could get it to do some cool tricks. Like you could make it scroll the screen downward by one line of text just by inserting uh, a character at the top of the screen. So that was pretty cool. So I figured out ways to like make it sort of work. And you only ever went up anyway. So, you know, and then I had like player missile graphics, kind of like chasing you. And it was very slow and crappy, but it worked. It was fun and no music or anything, nothing fancy. So this is like, my homage to Qbert. I was like, Qbert's cool. I'm gonna make my own version of that. So I started writing a version of that, and then I actually got it pretty far, and I had little guys that chased you, and but the thing was really slow. It like drew all the cubes really slowly in the start of the game, and I don't know how I drew them, but it must have been in a really bad way. And then uh, once the things were actually drawn and it was ready to go, it was like very slow in moving and chasing, and all of that was just really bad. So I did submit it to a magazine, probably soft side, I think it was, maybe Compute, and I got back feedback which was just like, oh, it's good but it's slow, can you speed it up? And at the time I must have been very busy with other things or depressed or something, but I never got it done. And I went on to other things and, got into, I don't know, whatever, making printer drivers and crap like that, and just making geek friends. So I never finished it. And uh, so now I've been kind of revisiting that and seeing what I could do to like rebuild it. And, it was going to be like, okay, Cubert's cool. What can I do? And other people had done, as it turned out, I'd found other versions. There was a guy who I knew in my general neighborhood on Cape Cod named Art Sestaro, who had done a version of Qbert called Kazoo and put it out as shareware, or I don't know how you but got stuff back in the day. You'd buy it in a plastic bag or whatever, and it was compiled BASIC and used some assembly to draw the sprites and stuff, and it was pretty cool. I had never seen that when I started on my version. I was just, going along, and then I met him, and I think we compared our versions, and his was like cool and goofy and had big, flashy, colorful graphics. It's called Kazoo. You should totally download it from the Atari Software Exchange or whatever. You go and grab a copy of Kazoo. I have a copy here. I should probably show it to you. It's really cute, but I'm working on my version, so I don't want to get too influenced by that one. But mine was called Snorky, which of course is a play on the word snorkel. Which Qbert had a big long snorkel kind of nose, so I guess it's a natural name. And then my idea was I'll have more cubes. So that's kind of where I'm at now, is just starting on building the cube pile. And you can kind of see here, if I uncomment this code, like this is how I was drawing stuff, like, you know, start with color, 3, plot, draw, 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 draw to make um, the top of the cube, and then move down a couple, and then go sub line 4 here, which was, draw one row of the angled sides of a cube. And so it would do that, and I could actually put this inside the loop probably to make it a little faster, but go sub, whatever. So anyway, that's the way I was doing it. It was, again, I think the way I did it must have been better than the way I did back in the day. I must have had fewer plots and draw twos or something, because it seems like it goes faster. Either way, as I've been working on it, I've been, optimizing it. So I started putting together a little system of a little makefile setup. So I can give you a little peek into that at the moment. Let's see, is this it? Yeah. So if I say make clean, you get the usual thing where it removes all the files. And you can see I have, so the things I needed to do, well, I'll give you a quick peek at what it looks like. So here it is right now it's loading. I'm not going to speed it up. Right now it's just loading. The list file is loading and being interpreted by the basic interpreter and tokenized. And now it's running. I've turned off the screen to turn off the DMA, and that's how fast that it just drew that pile of cubes. So that's pretty good for basic. Using just, now that's not using just draw commands. If I was using just the draw commands, it would be staggeringly slow compared to what you just saw. Now you can also see I've got a little walk function. It's just walking the cube pile, changing the colors of the tops of the cubes to test out my cube drawing functions. So spoiler, that's 6502 assembly code doing the drawing now. Previously, I actually kept around some of the code that was doing the previous drawing. Right now it's using these. So this is a USR function. This is how we would optimize our basic code back in the day. It's effectively you would prototype stuff, and I guess you could say, or at least I don't know if everybody did, but I certainly followed this basic pattern. Was if I could use basic to prototype it, I would, and I would start to like play around because it's very quick. Turn it on, basic is there. Start typing, boom, you're golden. There were definitely other versions of BASIC. There were other languages like Pilot, and I don't know. Atari had a couple of others that they were fond of. What other ones they have? Well, there was a C compiler, so you could use that. Yeah, Pilot was one. There was definitely other basics like Turbo Basic, and so you could use basics that were more optimized. You could use basics that were compiled, or basics that were both like this basic and compiled. You could use the ABC compiler to take this and compile it and make it run faster, which was something I definitely did later on, but I didn't want to necessarily depend on that, which is kind of ironic and weird because, well, who cares, Use BASIC as your language that you can actually run, which is kind of cool. And then you can also compile it and it runs way faster. That's really cool. So if you think about, more languages should be like that. Like imagine if you could just be typing, well, I guess you type your Python, you write it out, you're happy it works, and then you compile the Python into something that is, fully optimized. And effectively it does that just in time, each time you run it. But later it'd be nice to just have it be like, okay, now this is the final shipping thing. And I think that effectively a lot of these things now do that. You have packagers and so on. So, I haven't gotten too deep into all the packagers, but most of them effectively work in that general manner. Or they have like some kind of, standard library they ship with that they work on, or that they run with, like Electron. So anyway, so in this code here, I'm following some of the best practices, but I'll show you some of the codes that I wrote at first. So you can see drawing the cubes with draw commands there. You can see here I'm setting, I'm using poke as much as I can for colors, as opposed to just using set color, because poke uses just one variable and set color uses like the color number and the color group and then the color subindex, and it's like I only need two numbers. Just give me the two numbers. So that's what this does. Sets the colors for you. And I set this thing called theme colors, so you can kind of see if I run this again in the emulator. One of the things that I had to do was I wrote a little routine to like just play with the color themes, and the simplest one I came up with, of course, was well, we just use a color theme where all the hues are the same, but the luminance is different. So kind of like other games that you may have seen that are like this. And I don't have it set to change theme right now, but it will eventually like hit a random number and it'll change the theme color. But basically I wrote a little thing that fades it out and then fades it back in. So that's one of the things that I would demonstrate how to optimize in my next video on this topic. I'm just giving you the basic overview today of how I've done it so far. But as I go through this writing this and implementing this game, which I might submit to ABBUC, 2026. I might submit if I have it ready in October. Uh, but as I go through this process, I'll document what I'm doing and give you guys an overview. But at the moment, I had a routine that was doing whatever, doing go sub 10 or go sub, to print the cube, to draw the cube and stuff. And then I changed that. Now it's, uh, and then here we have drawing a blob that I move around. So yeah, I have the things I wanted to get in here were like, okay, then make sure I got my player missile graphics working, sprites basically. Make sure I have some the graphics mode I know I want to use, which is 4-color, 160 by 192. So I got that sorted out. And then I, make sure I got the right player missile mode and all that. And then, just sort of get my bearings on, okay, what am I gonna, how do I start? Got to draw a little guy, got to draw some cubes. So I'm going to be getting into like doing the actual graphics pretty soon and figuring out what tools I want to use for that and so on. But the so the essence of this was let's get the cubes built. So I did that stuff, got that built out, and then I wanted to get each part exercised. So the first thing I did was I made a thing to do a move of player missile graphics. So to make that, I created a ASM file uh, under, and I'll just have a folder for these as I'm gathering them together, because each of these is going to be a separate USR function, you could say, inside of the basic. And so I had, you know, 4 next loops drawing player missile graphics, obviously very slow. Really, the way you want to do it is to use 6502 whenever you can. So here we have the assembly language, and first thing is I know that I can use some bytes at CB, and there's some you can also use, like when you're running your program, there's some bytes that BASIC isn't using and doesn't need while you're doing like a routine. Like for example, your BASIC is not doing using FP0, which is like the fixed point or floating point 0 number that it uses for calculating things. So while it's not using that, you can use it for your own purposes or calculate with it or whatever. So that's one of the things is I know I have 7 bytes at at CB and probably more most of the time. So, and as I get the game built out, I'll be able to choose what 0-page memory locations I want to use. And when BASIC's not around, you get a lot to choose from. You might still want to leave some around for the disk I/O, which does, and the operating system has some 0-page it needs, but the BASIC doesn't necessarily. So now I've named this, but it doesn't really need a name. But here's how it works. You call USR move, which is what I've named it in the BASIC, and then you pass it the sprite data that where it is, like which is basically which. Let me see. Yeah, this is basically which player it is. So if it's player 0, it's going to point at the address of the player 0, the top of the player 0 sprite data. And then you have like how big is the sprite data, what is the x coordinate, what's the old y, and what's the new y. So what it's going to do is copy the sprite data from the old y to the new y and remove it, basically set it back to 0. So this is not a fancy routine, and it's not meant to be as fast as possible or to do logic like figuring out whether it's moving forward or backward or other things. Well, it does do that part, but but what it basically does is, as you can see, when you make well, this is one of the things you should know starting out. Is what the heck is a user routine, why, and how does it get called? Okay, first thing is, here's what I've done typically in my program is made it, you'll have a variable which is the address of a string, and the string contains all the bytes of the compiled assembly code, machine code. So that's all these bytes here which are funky characters, are the code itself, and then this move now points to that address. And so I can use this move variable as the address to call using a USR function. So up here we have move is somewhere. Where is it? USR init, USR move. Where are you? USR move. Oh, I put it at line 16 for some reason. Okay. So yeah, here it is, USR move. So it has to return something. So I say ER equals USR move. And then I tell it where the player 0 is, and then it's 5 bytes, and then here's the X coordinate, here's the old Y, and here's the current Y. So that's what all that does. So what this will do is it'll pass, first it'll pass the number of arguments. Well, first it needs the address, of course, of the thing you're calling, move, and then it needs whatever variables you're passing. So you'll get the number of variables in 1 byte that you pull from the stack, and that'll be, in this case, 5. And then that way you know how many you've got. So if you know variable number, like you say you can leave 1 off, leave 2 off, you can just know that in advance and it'll work fine. You can have these use variable arguments, so pretty cool. So all these will be passed as 2 bytes. So even though these might be 6 bytes or whatever, or variables, they're going to be converted to 2 bytes and passed each time this is called. So that's part of the overhead for anything, is, it has to convert it. But once it's called, now you get all the speed of 6502 assembly. So it enters this routine. You pull the accumulator, which has the number of arguments. You can make sure it's 5. If it is, you're good. If it isn't, I exit. I could just, ignore this here and save a few bytes, make it faster. Again, if you know that things are safe, you can remove the debug code later. So we have the next 2 bytes are going to be the address that we passed of the player, like the player data. And so we immediately put that in the high byte of a few of our pointers. And then we pull the next low byte and we store that as the pointer to the player. And now we pull the next 2 bytes, and that's the size. Pull the next 2 bytes, and that's our X coordinate. We're going to just store that directly in the hardware register for the player X, player, or, sprite 0, I should say. We're subtracting 4 because we're going to be centering. So everything is relative to this like center point. So when I move a sprite to a particular place, it's going to be like moved off center. So this is one of the things I've decided for this particular game. It's going to be easier to center things. So now we do pull accumulator, and we get our old Y. So again, it's pulling it off the stack. And we store that up here again. Got a few bytes reserved for this. And notice we already stored the high bytes of those. The source and destination addresses are already stored relative to the player. The thing is, each of these players is 256 bytes tall. So that's very convenient because it means our low byte can function as the Y coordinate, and the high byte, we don't have to worry about it. It just is the player. It's the same as the player pointer. So you're good to go at least within that 1 page. It's called 256 bytes is called a page on these old systems. So now we store the source and destination coordinates for the Y. And then we have to do a few little things. We load X with 0. We compare the source with 0 if it's, if basically, I should say we're comparing the accumulator, which was the destination we just got, to this value here, which we stored in the source. We could do this comparison earlier. Like we could say compare maybe to p source right up here before we store it in the destination, and then decide to exit at that point if it's 0. So, but it's more clean. It's more clean to kind of do it here in this way. In any case, we needed a 0 to be an X for some reason. We don't necessarily, but like we could put it, say, here, but we worry if you're writing to registers, like is it like the X, is it going to change the carry flag and so on? It won't, but you know, you worry about things like that. Like, so I probably shouldn't do, load it here, so on, and then do the branch and carry clear because it'll seem like I'm responding to this. If you know assembly language, it's like it gets meticulous. So again, here now we're taking Y, which we originally, you'll notice up here the size was transferred to Y. So I stored that temporarily. I don't know if piece size is used. Yeah, there it is. It's comparing it there. So we still store something there. So here we're decrementing Y, and now we're doing the loop where it's loading the sprite data from the sprite, storing it, and depending on this is the other thing we do is we just compare to see, if the source is above or below the destination. You have to copy the data either forward or backward so that it doesn't overwrite what you're copying as you're copying it. It's a common pitfall. Also, we do the thing where if it's nothing needs to be copied. So this is kind of a little trick where it's just once you've got the sprite data in the sprite, you can just move it around rather than copying it from a source buffer where the sprite data is. Of course, later on, I'm going to do animation and other things, so I won't be using this trick. But I just needed this as a kind of a proof of concept to kind of like get myself warmed up in 6502 again and get used to copying things and seeing what the tricks are and so on. So yeah, and this is compiled so we got the loops, we're doing the copying and so on, and then we return and we're done. So that just makes copying the sprite that like much faster. It's very fast. So right here I have it going to like 13,000, but I could go to like I guess 12 instead. And that'll be joystick handling code or whatever. So you can see this is where I'm exercising the player movement. Is like you typically almost never, I would say almost never in Atari BASIC do you ever want to copy player data using BASIC. You just want to be doing it using let's turn on a joystick. You definitely want to be doing assembly language or string manipulation, one or the other. So there we go. There's our sprite. I'm got in a little thing where I'm moving up and down the cubes as I will later in the game. So you can see I'm exercising some things. But yeah, the player draws really fast. Oh, of course, if the X moves before it while it's on still, so I should sync it to the screen really if I want to do it correctly. Is only draw when the beam is off the screen. But anyway, that's pretty good. That's pretty good. So I see one pitfall I'll have to watch out for later. But yeah, so that'll be cool. And yeah, I'll be using an interrupt probably for that, or not interrupt, but some kind of, maybe I'll have it in the vertical blank. I'll have a flag that says draw sprites now. There's no reason not to really, because if you're going to have a vertical blank, you can do whatever you want. It's going to take time away from your program, but if your program was going to do that anyway, and you don't need to do it more than 60 times a second anyway, and you don't, synchronizing with the beam is a good, is a good thing. You can also do things like wait for the vertical blank to occur in your program, but typically, like in BASIC, that's kind of almost pointless. But if you're calling a routine an assembly that does that and waits and then does its drawing so it synchronizes, it's not necessarily bad. You're only losing that one, maybe 1/60th of a second somewhere. And for, this level of programming and animation speed and so on, you don't necessarily need it. But that's kind of the thing, is you build the things the way you need them, and then later you can do the optimization. So the other things I added were, an init routine, which is just, very quickly zero out the player missile graphic area and then initialize the different registers for turning on player missile graphics so that it was so this is the kind of thing which would be very standardized. Like this routine, this user routine should be in a gist or a library of common routines that you would use all the time. Some of the things you'll notice is like after I got my 7 bytes, I told it to just put this at page 6. Page 6 is a 256 byte area that's typically available. When you're using BASIC, I just chose it arbitrarily because this code is meant to be relocatable. There's nothing that points to a particular address. And when the binary is emitted, it just emits all the bytes and not any header or anything like that gets emitted. If you want to add a header when you're building with these types of tools, you can add that. You can add a footer and header, whatever, or to your file. But in this case, new did not. And so we get just the raw bytes out. And I'll be showing you my make file shortly, which is pretty cool. So the init code just does that kind of thing, and you'll see that init equals whatever in here somewhere. So there it is. Init does all this. And you can see as a routine, not too huge. It's, some number of bytes. I don't know, what does it say? 46 characters. So not too huge. As long as things aren't enormous, you're good to go. My biggest routine is this cube routine, which you can see extends as far almost to the end of where the last margin is. In this code, it's ridiculously big, and in fact, I did everything I could to get it to fit exactly within the space allotted or allowed. But I'm going to split it up into 2 routines and with separate data and stuff later. So, and I'll probably do the same with like, I think with each. The thing is, you can split these things up in all kinds of cool ways. You can say, oh, I want my game data to be inside of one of these strings, and I'll just point to the address of that string as the game data, and then point to that when you call the user routine for drawing your sprites. You can just, here's the game data, and it'll look it up in the game data, and so there's the cool ways you can get around like these things getting really long just by splitting them up and moving the data around. Like I've got the data embedded in here. So that is the next part I wanted to do was, okay, so I had all my cube drawing routines and they were really slow and sluggish. How fast can I make them? And of course the cool thing is the way that it turned out is maybe just by luck or just by happenstance. The cubes are exactly 8 pixels, I should say, wide. And therefore I can split them up into, and that means, with 2 bits per pixel, that means they're 2 bytes wide, and they're aligned perfectly to these, center boundaries, and I never need to draw them aligned any other way, so that simplifies things a lot for drawing. All I have to do is copy bytes or them onto the screen. So that's what it does, basically, is it just totally does the bytes by oring them onto the screen. So I wrote this little routine well, first I went and dumped the screen memory and grabbed the bytes from the screen memory so I wouldn't have to think too hard. And then I got those organized into these data structures here. So there's the cube body that we need to draw. And then there's the cube top. Oops, that should be a period. And the cube top is basically, it's this. And I don't know if I still need these zeros here, because of the way I was drawing it. I might still, but I'll come back to that at some point. Just because I think that's because I wanted the coordinates to align so that this is aligned exactly with this here. The center of the cube is aligned with the center of the top. So the cube top, simple diamond shape. Cube body, same idea. Cubey shape, color 2, color 3, and these are the bytes that represent it. Every set of 2 bits is a pixel. I could have done these out in binary, but I didn't. I just didn't because it doesn't look good in binary. It makes more sense seeing them as the colors like this, 3, 2. I guess you could call this base 3 or something, or base 4. I'm not sure. I guess it's base 4. So these are base 4 numbers here. If there was a base 4, that'd be cool. So that's those, and then so once you have the data, what I'm all I needed to pass to this was its own address, since it doesn't know its own address. I guess it could like get the current like program counter and put it somewhere, but I don't know how you would do that exactly. I don't know if that's something you can do. Maybe there is a way to do that, but I opted for passing the address to itself, and then it just figures out from that where the cube data is, like based on the offset, because it knows it's offset from the top of itself. So I just use that, but I could also separate the data, and that's probably the better idea, is to separate the data into um, its own thing and point to that instead, or pass the address as x plus y or whatever. I'll put it in its own thing. Probably is the better way to do it. Anyway, the reason I say that is because I was running out of space and I just wanted this to be smaller and be able to keep doing things with it. But anyway, let's quickly go through what it does. It's very simple. One of the things I did add to this was I put a bunch of macros at the top. This is where the rubber meets the road when it comes to assembly language. Is you don't want to keep typing stupid formulas over and over again every time. Like adding to a pointer is the same 5 lines of code or 6 lines of code every time. Load the accumulator with the thing you want to add. Add, store, load, add, store. Clear the carry flag or whatever. And so I wanted to make macros to do that. So that's what this is. This is basically a 2-byte pointer. Add the accumulator to it. This is do that, also clearing the carry flag. This one means it's already clear. So then you have, copying data or ORing screen data. So I'm loading from the cube data, I'm ORing the screen, and then I'm storing back to the screen. This is all about ORing. So, and then if I need to clear it for like the cube top, I need to like do an XOR and then an and then a store. Even though this is a redundant, that's how you clear it. I don't think I use that for anything, but you get the idea. You're loading bytes from thing. You have to use the Y as the index when you're doing this. That's the addressing mode that we've got here. And I'm using Y because I need to get 2 columns of 2 bytes that are next to each other. So it's just more convenient to be like get byte 1, get byte 0, get byte 0, get byte 1, etc. And so on and so forth. And then we have the actual like, let's see, drawing of a cube top here where it does again, get the source bits, invert them, use an and, then store it in a temporary location, which I call y off in this case. Which, since we're not using y off, I can use it as the temporary location. So that's what I'm doing. And then I get the data again, and it with a mask that's been passed to the function. We'll talk about that. But it's just the color. If you want to have it be color 1, it's 5, color 2 is AA, and color 3 is FF. You can see why. And you just and that. And then I OR that with the screen bits and store it in screen bits. And then you got it. You're good to go. So pretty cool way of, copying this cube to the screen. And then we do it in a little loop. So that's basically just going to be one line of drawing, and then the same here. And we do it when we do a line of drawing. You'll notice I have this trick where I do increment y, so we get the first, comma y being 1, so we get the 1 on the right. Then we decrement y, and if it's not equal to 0, we go back here. Or if it is equal to 0, I should say, we go back here. And if it's not, then we increment it again, so it's back to being 0, because we need it to be 0. So that when it comes back here, it's 1 again, and then so on. So in essence, the reason it's done this way is so that this is not repeated more than once. It only happens once. If I had to repeat this code more than once, it makes the code too big. So that's why it works that way. And then I don't know how whether this like uh, identifier like only applies inside of the macro. I think it does. So because it's got an at symbol in front, so let's hope it's the case. Anyway, the way this one works, again, I pull the accumulator, I check, see if it's got 4 arguments, and if it is good, it continues. Otherwise, it returns. In this case, I'm commenting them out because it made the thing too large. I pass the data, I pass the mask, I pass the XY. So that's basically your color. And then your XY position for drawing it on the screen. It's only going to draw on 4-bit boundaries, so it doesn't care about the lower 2 bits of X. So it throws those away. It does all these other tricks. So basically, get the address of the USR, get the, what's the address of the cube, and then it does it all here, adding it on. Then it does load. See, I'm kind of peeking at this and going, could I make that optimized by loading that and then doing... No, because you can't do a load accumulator because you'd blow away the accumulator at this point. We don't want to do that. So moving on. Anyway, get the screen address. So you'll notice, yeah, you always have to do this thing where you get the add 0 to the high byte with, it's just one of those things. If there's a carry flag, it'll add it. If not, it won't. You could also do a branch and carry clear kind of thing, and skip this that way, where you say, like you could say ink cube +1 when you do that. So that'd be another way to make it smaller. I might look at that as an alternative. Because yeah, because I'm not, if you're only going to be adding 0, you might as well do the branch and then ink. I think branches are costly, so that's why you typically don't do it. Like branches taken are cost more than just doing the load, add, store. So I don't know. I'll have to look at that in the future. But anyway, that's assembly for you. There's always you're always looking for those little optimizations. So anyway, then we do a thing where we're copying the screen address. So I need to know that so that I can add to it in the near future. Then I get the bit mask that we're going to be using. That's the color. I could get that earlier, but we get it here. Like I could get it here, for example. Before yeah, it might be good to just move it here. Let's do that. There you go. So now we get the screen address and we store it into the destination. And now we get the X position. And let's see. We set carry, we subtract number 4, divide by 4, and now here we do the add to pointer trick. So that's better than typing all that code out. So that's using the macro, and it's just adding it to whatever's in the accumulator is being added, and the carry is already assumed to be clear. No, it doesn't have CC on it, so it's going to clear the carry for us in this particular case. So anyway, that's cool. You have to clear the carry before you add. You set it before you subtract. I almost forgot that at one point, and so I was like, why is this off by 1? Then I figured it out. So anyway, yeah, it takes that X, it subtracts 4, and then it divides it by 4, puts it in the destination. So now we've got the X accounted for. Now we have to deal with the Y. Each line, spoiler, in this graphics mode is 40 pixels wide. So we need to multiply by 40. So first we get our Y offset. We subtract 3 from it. We multiply it by 2. So we now have it by 2. And now we're going to be multiplying it by 4 when we get into the loop, so that we have 8, and then we can do that again, so we end up with times 32. And by doing that, we'll magically end up with 8 plus 32 equals 40, which is exactly what we want. So this was a little originally a little bit more unrolled, and I tightened it up. So using, again, a little clever looping trick with the X being set to 2 and doing that little loop right there. So anyway, that's all. The only thing that's happening here is this entire loop exists to multiply it by 40 and add that to the destination address. So first it adds the value times 8, and then it adds the value times 32 to get a total of the y offset times 40. So that gives us, now at this point, the destination address finally points to the where the cube is going to go. So yeah, that's all the work I had to do to just to get XY to point to the cube is all this stuff here. So yeah, now you can imagine, like, gosh, that sure seems like a lot, but when it comes down to it, like, it's going to compile down to, like, 20 bytes or something ridiculous, like 30 maybe. So yeah, it's a tiny price to pay, but when you consider that 5 decimal numbers in Atari BASIC are 30 bytes, and this whole routine that does all this clever stuff is 30 bytes, in loops and everything, it's worth it. So yeah, this does a little loop of 2 to multiply it by 40 and add it in. Now we draw, finally we get to the place where we get to draw the cube. So we put 0 in Y, we get our color. In this case, if it happens to be 1, we're going to draw the body. So that's what I decided with this, is like, number 1 means draw the body, and anything else means here's the mask color. So let's go. So that's what it does. If it's 1, it jumps down to draw the body. Otherwise, we draw the top of the cube in the color that was given. So first we need to add to the cube address. So we just need that in the accumulator, distant difference between the cube top and the cube body. And boom, now we just need to put the size of the top of the cube into the X, divide that by 2, because each line is 2 bytes. And then we do a line draw of the top of the cube, and then we add 2 to the cube, and we clear. We know that the carry flag flag is clear at this point, so we don't clear it. And again, we load 40 and we add that to the destination because the next line down. And then we decrement X, so we get the whole top of the cube. And when we're done, we return from subroutine, which returns. And we don't have to do anything funny with the stack or anything. Once we pulled everything off the stack, we can just return. So that's all good. That's the one thing you do have to do, is you have to make sure to clear the stack before you return. You can't just ignore stuff on the stack or leave it there, just because you're not going to use it. You got to pull it off and just throw it away if you're not going to use it. So that's pretty cool. So now if we draw the whole body of the cube, again, same idea. We do a body line draw, which is ORing the cube body without any of the XOR stuff. Because when we do the drawing of the cube body, we know the screen will be clear at this point because we're only drawing the background. Maybe later we'll be drawing cubes, like adding rows that aren't there yet, but it'll typically only be going down anyway. It does ORing of this stuff, so even if it was, as long as we're drawing over what was already there, it's not a big deal. It's just that when we draw in weird offsets that it could be screwy. Anyway, we load accumulator number 2, we add again to the cube, we add 40. So it's exactly the same loop, but we're doing a different thing here. And we've got a different number of things that we're drawing. So this is to be optimal, and again, this is pretty cool. It works. If I could get it down even more, that would be great, but for now it's fine. The body line draw stuff uses the Y in that way that we, where it starts out, as long as it starts out being 0, it does the right thing. And then finally at the end, we've got the data. So yeah, very simple. Having copied the data, now to actually build it, and this stuff, we just do make, and I typically do test list, which makes a file, which you can see. I'll show you the make file. So the make file is pretty straightforward. Snorky helper code. It does the init code, the sprite code, the cube code, and whatever else I end up adding. And then it has this test this test code listing that it emits, which, I typed all this in BASIC, of course, and moved it over here, but it automatically inserts the built code into the program right here, this part. It turns it into an init equals address of a string, move equals address of a string, cube equals, so it's all nicely arranged. And then the final result is you get this list file, which comes out, and when you run it, it exercises each of those things. So let's run this one, and you'll see this one runs a little quicker because it doesn't have as many lines, but there it goes. It draws some things. There we go. It draws some cube tops. And then if I turn on the joystick, it will let me move this little diamond around to exercise the sprite stuff. So there, we see that all those things have been built and they all work inside the emulator. So pretty neat. Yeah, so that's pretty fun. Then the other thing I wrote inside of Snorky was a random walk thing, which I think I stuck in at, where is it, 13,000? 13,000. Yeah, so this is the random walk. There we go. So, yeah, so once it's all put together, I was able to just, bring these routines into the program and start using them. And so the next thing that, as I mentioned, that's going to be slow in this program. You can see how quickly it draws when it's in, turbo mode. But yeah, you can see here's the fade between palettes, I think, maybe. Did I turn that on? There it is. Fading between palettes when I have the controller turned on. Here we go. So you can see I've got all the palettes set out here, playing with that. So that's the next thing I'm going to optimize. It's a little bit chunky. I don't know if you notice, but when it does the fade out, like the colors aren't necessarily aligning exactly. So that'll be the next thing that I'm going to optimize into 6502 assembly code. And then, of course, now that I have the basics of, drawing the playfield, the next thing will be bringing in the players and missile graphics, or sprites as we call them these days, and testing them to see how I can do animation and move them around on the playfield and have them do animations like jumping from cube to cube and rolling down or whatever else I want to add, or flying over, or other things. So that'll be another fun level to get into. So between now and then, I'm going to be working on, I'll be double teaming it, working on Marlin and working on retro stuff. So this has been a fun process of getting the stuff together so that I have a process to do the building of the basic framework scaffolding that lets me develop the game idea and build it out in simple, basic logic in a very quick turnaround kind of way. And now, after I have that sort of settled and some of that is built out, I'll be taking that basic code and we'll be throwing away pretty much all of it, because at that point it's just going to be a bunch of logic like, if the score is greater than 5, go to line 10, and you can write that stuff up in assembly language. Like, it's the easiest assembly to write. The hard stuff to write is like algorithms and funky routines where you only have your A register, your X register, your Y register, and some 0-page pointer values or whatever, and you have to figure out how to use those resources and within a time, a tight time frame or whatever. So I had a fun time doing like the assembly especially for the cube drawing, because that was something I never would have done back in the day when I was, doing my magazine code type-ins and stuff. Like, I wanted to do that kind of stuff, but it was daunting to like, oh, how do I build it and then have it in a form that I can then bring over into the program and have it all in a nice workflow. And like in modern times, we have the ability to, have the editor next to the emulator, next to the editor, next to all the other, the sprite thing next to the sound thing. So that's where it's going to be really fun. Again, towards the end of my career with this Atari stuff, I was building, printer drivers in assembly and building out like tools for doing sound and sprites and stuff to like, so that I could really like start to build out the things. But of course, it was the end of an era, and the stuff was on the verge of becoming obsolete, and I didn't know how much longer it was going to last. None of us did. It was crazy times. But now it's kind of making a comeback. We've got the Commodore 64 Ultimate out there, and I see that probably be some interest in Atari stuff, and the ABPUC, the ABUC competition every year is really fun. I really love looking at their stuff, and we'll review some of their stuff pretty soon as well. But on this here channel, so yeah, tune in, and I'll get into more of this basic optimization stuff. But probably by the time I get into the next video, or get time to like spend an hour with you, going on over what's been done, I might have, might even have all this transferred over into assembly at that point. But go to the project page. I'll have the link in the description once I get this posted on YouTube, I assume. And you can go to the 6502 project, 6502 tools project, and you can peek at this code in its current form. I'll try not to keep doing force pushes where you don't get to see the changes. You should kind of see it evolve as it go forward. At this point, like, it's like this is just the beginning. We'll see where it goes. I just thought this would be a lot of fun to make. I always wanted to get this thing done back in the day and have it out there, and really fill it out and give it a title page and everything else, and make it as fun as any Synapse game, or which were kind of the creme de la creme of what the best software, them or Electronic Arts, and others were getting more sophisticated by the minute, and I was like falling behind as a bedroom coder. So now I can kind of use my 40 years or so of extra time that I've had with this stuff, and I don't know, it's much more fun and kind of like quick to turn around to get these problems solved and just keep exploring. So highly recommend following along with me as I go through this journey, because it's been a long time coming, really, and I've had this Jones for a while. I even took one of the ABUC games and wrote it in Pico 8 just to kind of get that out of my system. Like, okay, I'll get, this really cool game and kind of get in the mood for, making something. So I did this Fallen Kingdom version, and I put it out on my website. I really need to update my website and other things as well. So a lot going on right now with big changes happening in the industry that I'm in. I'm doing my best to keep up and keep it going, but donations are slowing. So this is a new direction to kind of keep things interesting while things are slowing down on the 3D printing front. But they do dovetail together. Me and Richard Horn, we're like, we don't know each other, but we're in the same kind of wheelhouse. Retro meets 3D printing. So stick with us. We'll keep things interesting, and I'll explore more of Soft Side magazine too, and talk about that in a future video. So anyway, yeah, thanks for hanging out with me at this live stream. Probably wasn't a lot of you here. Oh, but be well, take care of yourselves, and I will see you really soon. Should we do the outro? Should I do the outro? What do you think? Might as well.
Retro coding live stream, everybody scream. Retro coding live stream, everybody scream.